We've already looked at solving linear systems of equations. Now we want to expand on those ideas to look at solving nonlinear systems. Many ideas that we established already will carry with us, but we'll also see some distinct differences between what we'll do now and what we did before. We can start off in example 1 by labeling our two given equations as equation 1 and 2. Equation 1 is going to look like the graph of y equals x squared, but shifted up 1 unit. So we'll have points at 0, 1. When x is positive 1 or negative 1, we'll have values at 2. And if we skip to 3, we'll have values at 10, and at negative 3, positive 10, or I'm sorry, at negative 3, positive 10. So we can sketch out this quadratic function, or I'm sorry, this square function shifted up by 1 unit. And then we can look at graphing our linear equation, which is going to have an intercept at 1 and a slope of 3. I am not always the best artist here, but if we drew this very carefully, what we would end up seeing is that our two graphs intersect at 2 points. The first would be at the point 0, 1, and the second would be at the point 3, 10. So that's our first difference, is that once we start looking at nonlinear systems, it's possible to have more than one point of intersection. In this case we have 2, we have cases where we could have 4 or more, just depending on our functions. In example 2, we could again label these two equations as 1 and 2. Equation 2 is the easier one to graph here because it's just a linear equation. If we flip that order around, we've got things in slope-intercept form. So we have an intercept at 4 and a slope of negative 1. So we have that straight line equation graphed. Our first equation, x squared plus y squared equals 16, if you're not familiar with that form, is the equation of a circle centered at the origin with a radius equal to the square root of whatever that value on the right hand side of the equation is. So in this case, a radius of 4. So we're going to draw a circle centered at the origin with a radius of 4. Which will help us see that in this case we have 2 points of intersection occurring at 0, 4 and at 4, 0. The idea here then is similar to what we've done in the past. In order to solve a system of equations, we need to find all xy coordinate pairs that make both of these equations simultaneously true. In example 1 and 2, we had cases where we had 2 points of intersection. If we draw a slightly different example, just sketching something out here, we could have a case where we have 4 or more points of intersection. So for instance, we could have a graph similar to x squared with some transformations applied and the graph of a circle, and we could have those two graphs intersecting at 4 different points. So we'll have this possibility of coming up with more solutions than we did when we were looking at just linear systems.